Good morning and I welcome you student. Last time I have discussed with you two important periodic classification which were given, one by Dauberiner, Dauberiner's law of triads. What he did, what was done by Dauberiner, he formed three triads. What he did, he formed three triads were formed. The basis of these triads were increasing atomic weight. So he arranged the elements according to increasing atomic weights. For example, lithium, sodium, and potassium. The atomic weight is increasing, and he found that these lithium, sodium, and potassium, they have similar chemical properties. They have similar physical and chemical properties. And the atomic mass of sodium was the arithmetic mean of lithium and potassium. So if I add the mass of lithium and potassium, divide by 2, we will get the atomic mass of sodium. So the problem with this was he could form only three triads. So this was of no significance. It was not very useful because it was applicable. Only three triads were formed by him. After that came the Newland law of octaves. Newland's law of octaves. The octaves is a word which is taken from the music. Sare gama panada. There are eight notes in the music. So what he said, he arranged the elements according to increasing atomic weights. He arranged elements according to increasing atomic weights. So increasing atomic weights से उसने arrange किए atomic weights or mass. And as the elements were arranged according to increasing atomic weights, he found the periodicity in the properties of the element. What he found, the eighth element has similar properties. Every eighth element is having a similar property. So he formed a table also. But what was the main limitations of the Newland law of octaves? We have discussed the limitations also. There are limitations of, these are important questions which can be asked in the paper. Limitations of Newland law of octaves. This law was applicable only up to for lower atomic masses. For heavier elements, it was not applicable. हाँ, तो आपने देखा था कि कैल्शियम तक ये ठीक रहा, उसके बाद फिर heavier के लिए it was not having, and there were a lot of difficulties also at that time. Also, there were less number of elements which were known, and also then this was of not much significance. The search was continuing. The best part of the Newland is there is a periodicity in the properties of the element. There is a repetition in the properties of the elements when they arrange in increasing atomic mass. That was a good point about the Newland. After this, it was clear that these two laws are not going to explain the or form a periodic classification of the elements, because as more and more elements were discovered, the credit to form a periodic table goes to the main name which we have written, Mendeleev. Making order out of the chaos, the Mendeleev 1834-1907. You can see Mendeleev is the person who did a large amount of good work in order to arrange the elements by using a fundamental physical property. Again, the physical property which was used was atomic mass. He arranged the elements according to increasing atomic masses. And at that time, when he started his work, about 63 elements were known. When he started his work, 63 elements were known at that time. When he started his work. Okay? And he examined the relationship between atomic masses of the elements and their physical and chemical properties. And he was mainly concentrating on the compounds formed by these elements by reacting with hydrogen and oxygen. What he found, hydrogen and oxygen as very reactive elements. So he was trying to react elements with hydrogen and oxygen and compare the properties of these compounds. On that basis and increasing atomic weight, he formed a table which is given here. We will show you. Let us see what we are saying. So the main credit for classifying elements goes to Dmitry Mendeleev. Main credit for classification. He was the most important contributor to the early development of a periodic table of elements, wherein elements were arranged on the basis of their fundamental property. Which fundamental property? Atomic mass, and also on the similarity in their chemical properties. So the fundamental property which was used by Mendeleev is atomic mass. And the second important thing is the similarity in the chemical properties of the elements. Chemical properties of elements. This is important. As I said, the chemical properties which were studied were mainly, he selected hydrogen and oxygen. The two elements, hydrogen and oxygen. They are very reactive elements and they were reacted with the elements to form compounds. They will be reacted with hydrogen and oxygen to form compound. Oxides banenge, hydrides or jo bhi compound banenge. On that basis, he found similarities in the chemical properties of the elements. So Mendeleev is often referred to as father of the periodic table. He called his table or matrix the periodic system. This was he called periodic system. Let us see what are those. Certain questions put up before the students many times in the exams also. How did Mendeleev arrange the periodic table? Mendeleev arranged the elements in order of increasing relative atomic masses. When he did this, he noted chemical properties of the elements and their compound shows a periodic trend. Periodic trend means there is a repetition in the properties of the elements. Everything periodic means it repeats after a regular interval of time. So when he arranged them according to increasing atomic masses, he found periodicity in their chemical properties. What physical and chemical properties did Mendeleev study? The physical property and chemical properties of element that considered while compiling the periodic table. Physical properties, in chemistry we do two things. Physical properties. Something is solid, liquid or a gas, that is a physical property. Melting point, boiling point, densities. So physical properties, he was studying their melting points, boiling points, density of the compounds of the elements. And in chemical properties, what is he studying? As I said, he was reacting with hydrogen and oxygen. Chemical properties, what he did, he reacted with hydrogen gas and oxygen. They are very reactive element, hydrogen and oxygen. So what he will form, hydrides will be formed and oxides of the compounds will be formed. So he, based on these chemical properties and physical properties, he found similarities. So these are important points, note down. Mendeleev used the formula of oxides and hydrides produced by the elements as the basic chemical properties of elements in creating the periodic table. And you will read about the history of this Mendeleev. At that time, hydrogen is easily available gas, oxygen is easily available. He was reacting them with the elements and forming the compounds. And that was the basic chemical properties of the elements. He had that. And then he How many elements? 63, and slowly few more were being discovered. So he observed most of the elements and he formed a table based on the chemical properties of the elements with increasing atomic masses. So he formulated periodic law. He formulated a periodic law. What periodic law he said? He said the properties of elements are periodic functions of their atomic masses. Properties of elements are periodic functions of their atomic masses. So atomic mass is again considered as a fundamental property by Mendeleev. And Mendeleev's periodic table contains vertical columns, and his periodic table contains Mendeleev formed a periodic table. Mendeleev's periodic table contains what it contains, student? Contains vertical columns. What are vertical columns? They are called groups. And horizontal rows. Vertical groups come like this as you go from top to bottom. Horizontal rows move like this from left to right. This we are saying we are going from top to the bottom. So and horizontal rows which are moving from left to right, are called periods. So there are vertical columns and periods. Vertical columns and periods. हाँ जी सर, वो मेरे यहाँ पे फिर से लाइट गई तो मैं पता नहीं कभी ज्वाइन करूंगा। अच्छा ठीक है, तुम कर लेना जब तुम्हारे को मिलेगा। अभी तो क्लास में तो वीडियो रिकॉर्डिंग तुम्हें मिलेगी जो भी क्लास चल रही है, ठीक है? यस सर। ओके सर। तो मेंडलीव्स पीरियोडिक टेबल में क्या है? देयर आर वर्टिकल कॉलम्स जिन्हें ग्रुप्स कहा जाता है, और हॉरिजॉन्टल रोज कहते हैं जिन्हें पीरियड्स कहा जाता है। सो यू विल गेट ग्रुप्स एंड पीरियड्स। लेट अस सी क्या इसका अरेंजमेंट है। Now here is a Mendeleev periodic table given in the NCERT book. You can see how many there. These are as I said, he has used oxygen and hydrogen reaction for comparing the chemical properties of the elements of their compounds. So we have in this group oxide and hydride. Oxide, you can see this is oxide, this is hydride. Oxide and hydride. And as you see, what is the formula of the oxides? In that group 1, this is group 1. As you can see, there is a group 1, group 2, 3, 4, 5, 6, 7, 8. You are able to see the 8 groups formed in this table. And in group 1, what type of oxides are there? R2O. So, and what is the hydrides? RH. For example, if I have hydrogen, then this becomes H2O, and with H it becomes H2. If I have Li means Li2O, lithium oxide, and LiH. So that is the formula of the oxide and hydrides of group 1. These are the elements of the group 1. How many vertical columns? 1, 2, 3, 4, 5, 6, 7, 8. As you will see here, 8 vertical columns are there. And in group 2, the formula of the oxide is not R2O, it becomes RO. The formula becomes RO. So what we are saying here, students, that you can see he was comparing the formulas of these. What he is comparing? The first group forming R2O oxides, RH hydride. Second forming RO, RH2 hydride. So if I take BE, then it is BeO. Oxide is BeO, and this is BeH2. BeH2. And if I consider group 3, this is my group 3 elements. For example, B, then the formula of the oxide will be B2O3, and the formula of hydride is BH3, like with aluminium also Al2O3, AlH3. Like this, he is comparing similarities in the chemical properties on the basis of 2 important, oxide and hydrides. And how many groups we have shown here? 1, 2, 3, 8. And in this side, as you go down, periods, you can see the periods here now. Period, first period you have hydrogen, second period you have lithium, beryllium, boron. These are second period. Period wise, you can see period number 1 from left to right, period 2, period 3, sodium, magnesium, aluminium, first series, second series. So you have 4th period, 5th period, and 6th period. These are the periods, horizontal rows. And horizontal rows are the periods. Vertical columns, you have groups. There are groups, as you will see, as you go, group 1, group 2, group 3, 4, 5. These are the groups. And as you move here, first period, second period, period 3, elements in the periods. So the arrangement has been done in groups and periods. Groups and periods. Mendeleev's periodic table was published in German journal 1872. In the formula for oxides and hydrides at the top of the column, R is used to represent any of the elements in the group. Note the way formula are written. For example, hydride of carbon is CH4, is written as RH4. So if I consider the 4th group, in carbon is present in the 4th group, and the formula of the hydride is RH4, means what is the formula for this carbon? CH4. For silicon, it will be SiH4. So in group 4, students, what we are saying, if I have group 4, the carbon is forming CH4, silicon is forming SiH4. These are the formula of the hydrides. And the formula of oxides in group 4, RO2. This is RH4. R is the element. And what is the formula of the oxide in group 4? RO2. RO2 means this will be CO2. This will be SiO2. So these are the compounds with oxygen. These are the compounds with the hydrogen. So like this table is before us already. This is given in 1872 by Mendeleev. How many? More than 63 elements were known, and slowly more and more elements were coming. Can see. Okay. Mendeleev, question, what is Mendeleev's periodic law? Already we said properties of elements are periodic functions of their atomic masses. The elements have been arranged according to increasing atomic masses in this Mendeleev's periodic table. Okay. Let us see what are the main characteristics of the periodic table. Question, what are the main characteristics? What are the main characteristics of the periodic table which are given by Mendeleev? First, in the periodic table, elements are arranged in vertical rows called groups and horizontal rows called periods. First, this is the first thing. There are 8 groups. You have seen how many groups we have indicated? 8 groups. And Roman numerals are 1, 2, 3, 4. These are Roman letters. And elements belonging to the first 7 groups have been divided in subgroup designated as A and B on the basis of similarities. Further, they have been divided in groups A and B based on the similarities in the properties. The chemical properties you already have seen: oxides and hydrides. Elements that are present on the left hand side in each group constitute subgroup A, while those on the right side of the subgroup constitute B. Group 8 consists of 9 elements which are arranged in 3 triads. There are 6 periods. How many periods? 1 to 6, or horizontal rows in Mendeleev's periodic table. The period 4, 5, 6 are divided into halves. The first half of the element are placed on the upper left and second half lower right in each box. Many gaps were left in the periodic table for undiscovered elements. This is an important point. Mendeleev was sharp enough to leave certain gaps in the periodic table. Why he left certain gaps? Because this gap was left for undiscovered elements. There are undiscovered elements which were later on discovered, identified, and were placed at their respective positions. So Mendeleev left certain gaps for those elements which were not known at that time. Noble gases could be easily placed in separate group called zero group. And further important point is, as noble gases were discovered, noble gases helium, neon, argon, they could be placed in zero group with a, what we say, zero valency. They are not reacting. These elements are very stable elements. They don't react. So valency is the combining capacity of the element, zero valency, without disturbing the main periodic table. So without disturbing the main periodic table, noble gases could be put in a zero group. So this is the table. You see what we have said: A and B, group 3A, B, like this. In A, you see the elements. In B, also you see some elements. Transition series. And in the periods, you see starting from first period, second, third, fourth period, again divides into upper half and lower half, upper half and lower half, upper half elements, lower half elements, upper half, lower half, fourth, fifth, and sixth periods. These are the main characteristics of the periodic table given by Mendeleev. Question is, what are the achievements of the Mendeleev's periodic table? What did he achieve? He is considered as the father of the periodic table. He has used a fundamental property, atomic mass, and used similarity in the chemical properties using a formation of oxides and hydrides by the elements. Achievements of Mendeleev's periodic table. Number 1, elements with slightly greater atomic masses were placed before an element with slightly lower atomic with an inverted sequence so as to group the elements with similar properties. For example, cobalt with atomic mass 50 was placed before nickel with atomic mass 50.7. So what he has done, slightly greater atomic mass is there. Okay? It is placed before the lower with an inverted sequence. The sequence is inverted. He left some gaps in the periodic table with prediction of existence of some elements which were not discovered at that time. This is very most important point. As he was saying, more elements will be discovered, and he has left gaps for them. He named the future elements by prefixing Sanskrit numeral Ika. Future element, he said, will be discovered. His name Sanskrit numeral Ika to the name of the preceding element in the same group. For instance, scandium, gallium, and germanium discovered later. These were discovered later. Have properties similar to Eka. Eka means boron. Scandium has properties similar to Eka boron. Gallium has properties, Eka means similar to aluminium. And germanium has properties similar to silicon, Eka silicon. What they call as Eka boron, Eka aluminium, Eka silicon respectively. So he has put a Sanskrit numeral Eka. Eka means same property. Eka boron. The element will be discovered Eka boron, which will have similar property to boron. Element Eka aluminium, property similar to Eka aluminium. That will gallium was discovered later and had properties similar to aluminium. Then he says Eka silicon property, which is similar to silicon, was germanium. Eka silicon germanium. Further, noble gases like helium, neon, argon were discovered later as they are present in exceptionally low concentration in the atmosphere due to inertness. Atmosphere contains some gases which are not reacting, which are inert gases. Noble gas means which do not react. These are helium, neon, and argon. They were discovered later. They were called noble gases. Noble gases. The boldness of Mendeleev's quantitative prediction and their eventual success made him and his periodic table famous. Mendeleev's periodic table published in 1905, as shown in figure 3.1. Now, interesting thing, what do you see? You can see certain properties, as we said. I have shown you that Mendeleev has left certain gaps for the elements which were not known at that time but discovered later. For example, he predicted Eka aluminium element, and predicted, and he said that atomic weight will be 68. Density will be, he even predicted their properties also. Melting point will be low, and formula of the oxide will be E2. E is an element, E is the element, E2O3, and formula of the chloride will be ECl3. And what was found? Gallium. Later was gallium. Gallium is Ga students. And it was found the gallium has atomic weight 70, very close to this. And density is also 5.94, very close to this. And gallium has a low melting point. Oxide of the gallium formula, Ga2O3, was found. Formula of the chloride is GaCl3. So this was very important result. Eka aluminium, similar to aluminium. Then Eka silicon will be an element which will be having similar property to silicon, he predicted. And what he predicted, atomic weight 72, density 5.5, melting point will be high, compound will be, oxide will be O2, and chloride will be, and what was discovered was germanium. Germanium formula is Ge. It was discovered later. And the Eka silicon space has been left, gap has been left in the table by Mendeleev. He found, it was found that this has atomic weight 72.6, very close, and density also, see, almost 5.5, melting point is high, and oxide formulas Ga2 as we predicted, Ea2 and this, they matched. So the properties are matching. The elements which were not known at that time but were discovered later, their properties are matching with the properties given by Mendeleev and leaving the space in the table. So this was a real success, and that's why the table became very famous, Mendeleev's periodic table. Now the question is coming, student, what are the limitations of Mendeleev's classification? What are the हाँ बोलो
सर 3 o'clock हो गए।
अच्छा ठीक है, कोई बात नहीं, कंटिन्यू चलेगा, मैं इसका वीडियो भेज दूंगा, थोड़ा हो रहा है अभी, कोई बात नहीं। लिमिटेशंस, मेंडलीव खत्म होने वाला, ये मेंडलीव खत्म होने वाला। लिमिटेशंस ऑफ मेंडलीव्स क्लासिफिकेशन, व्हाट आर द डिफिकल्टीज, व्हाट आर द लिमिटेशंस ऑफ मेंडलीव्स? फर्स्ट इंपॉर्टेंट थिंग इज हाइड्रोजन पोजीशन, वेयर टू पुट हाइड्रोजन? Hydrogen resembled properties of both alkali metals and that of halogens like iodine. Hence the position of hydrogen, whether it is to be placed, where to place hydrogen, because it has resemblance with alkali metals which are lithium and halogens like iodine. Should we put it in halogens or with these alkali metals? So the position of hydrogen to be placed with halogen, or it was not specified. The position of hydrogen was not specified. This is one of the limitation, hydrogen position. In the table, not specified because it shows resemblance with both alkali metals and halogens. Second problem, position of isotope. This is very important point. What are isotopes? Which have the same atomic number but different mass number. Those elements are called isotopes. So isotopes are those with same atomic number with the different mass numbers. Mendeleev table was based on arranging elements in increasing atomic masses. So atomic mass of isotopes are different, but they are same elements. Atomic number is same. Therefore, this is a very serious problem. So isotopes were not included in periodic table. But position of isotopes, position of isotopes cannot be explained by Mendeleev, cannot be explained, and they are not included in the periodic table of the Mendeleev. Third, certain elements arranged in reverse order, elements having higher atomic mass were placed in front of the elements with less atomic mass. For example, cobalt and nickel. Cobalt being heavier than nickel was placed before nickel. So cobalt is heavier but is placed before the nickel, but he is arranging in increasing atomic masses in the Mendeleev periodic table. These are the limitations of the Mendeleev. As we said, electronic configuration of hydrogen resembles like alkali metals, and like alkali metal, hydrogen combines with halogens, oxygen and sulfur to form compounds having similar as shown. On the other hand, just like halogens, hydrogen also exists as diatomic molecule and combines with metals and non-metals to form covalent compounds. So hydrogen was showing resemblance with group 1 elements and also with group 7 elements. As it's forming, this hydrogen is forming HCl, H2O, H2S. These are covalent compounds, and also it resembles with halogen, like sodium chloride. If you see sodium plus and Cl minus. So these are the compounds of hydrogen. These are the compounds of sodium. Sodium is an alkali metal. Sodium is an alkali metal. Sodium forms NaCl, hydrogen forms HCl, sodium forms Na2O, hydrogen forms H2O. So these are show resemblance of the hydrogen with alkali metals. On the other hand, it also hydrogen exists as diatomic molecules H2 and combines with metals and non-metals to form covalent compounds. The position of hydrogen was not explained, and as isotopes were discovered long after Mendeleev had proposed his periodic classification, the isotopes of an element have similar chemical but different atomic masses. These are the isotopes of chlorine, but atomic masses are different. Would you place them in different slot because their atomic masses are different, or would you place in the same position? This was the problem with Mendeleev because where to put these two? These are the same atomic number, but different atomic mass. Their element is same, chlorine. Now atomic mass 35 and 36, then where we will put in the Mendeleev table. Thus, isotopes of elements posed a challenge to Mendeleev's periodic table. Another problem was atomic masses do not increase in a regular manner in going from one element to, so it was not possible to predict how many elements could be discovered between two elements, especially when we consider heavier elements. So these are the achievements and these are the limitations, problems of the Mendeleev. That is why we know Mendeleev periodic table has limitations and there is a need of a better periodic classification than Mendeleev. And one of the main problem which was coming is that Mendeleev has been using atomic weight as a fundamental property. Later on, we will find in the modern periodic table that the fundamental property which has been used is not the atomic weight, but atomic number. So the problem with isotopes is solved when elements were arranged with increasing atomic number. And the next class we will discuss the modern form of the long form of the periodic table and certain trends in the periodic table. Okay, then I will meet you in the next class.